So next point here is 2.3. SI unit of distance and displacement both is meter. CGS unit is centimeter with the connection that 1 meter is equal to 100 centimeter. There are certain other larger units of distance which are light year, parsec and AU. AU, or the astronomical unit, is the average distance between Sun and Earth, and it is equal to 1.496 into 10 is to power 11 meter. Then we have 1 light year, which is distance traveled by light in a duration of 1 year, and it is equal to 9.46 into 10 is to power 15 meter. Then we have 1 parsec as 3.26 light year, which is equal to 3.08 into 10 is to power 16 meter. Then we have the concept of velocity. So first is dimension of velocity is m0 L1t minus 1. It's a vector quantity, its SI unit is meter per second, CGS is centimeter per second. It is of two types. First is average, another is instantaneous. Average velocity is displacement by time. Instantaneous is dr by dt. Then we have certain graphical based question. Suppose this is the position time graph of a particle and we have a certain point A. We draw tangent on the graph and angles in clockwise sense is alpha and in anti-clockwise sense is theta. So we have velocity as dx by dt, which is tan theta, which is also equals to minus of tan alpha. Now we have certain comparisons based on values of theta. So if theta here is less than 90 or acute, then tan theta will be positive. That makes velocity as positive. If we have theta as 0 degree or 180 degree, tan theta will be 0, so velocity here will be 0. If theta is 90, then tan theta will tend to infinity, so velocity will also tend to infinity. If theta is greater than 90 degree, tan theta will be negative, so velocity will be negative over here. Now we have different graphs based on these. So first of all, we have the xt graph like this. So we can see that at this particular point, theta is less than 90. So tan theta here will be positive. So acceleration here will be positive. Then we have another graph in which theta here is 0. So tan theta is 0 and hence velocity, it's not acceleration, it's the velocity. So velocity will be 0 over here. And if theta is 90, then tan theta will tend to infinity. So velocity will tend to infinity over here. Then we have this question here, theta is greater than 90. So tan theta will be negative. So here velocity will be negative. So these are the graphical analysis. Then we have in xt graph, suppose this is the motion of the particle, and if we draw, we need to find average velocity from the xt graph. Then we know that average velocity is displacement upon time. Displacement here can be written as xp minus xa. Time can be written as tb minus ta. So it is equal to the slope of secant in this case, as you can see. Now another point is that of speed. So regarding speed, the first thing is it's a scalar quantity. Second, its SI unit is meter per second. Third is its CGS unit is centimeter per second. Fourth is the type of speed, and in type we have average speed and the instantaneous speed. Well, average speed is distance traveled by time taken, and instantaneous speed is the magnitude of instantaneous velocity. And then we have acceleration. So acceleration is a vector quantity. SI unit is meter per second square. It can be CGS unit is centimeter per second square. It can be categorized as average acceleration and the instantaneous acceleration. One more thing here, dimension of acceleration is m0 L1t minus 2. This is also important case in this. So this is the second video on this. If you have any doubt, you can ask in the comment section. Thank you and have a nice day.